Good afternoon to everyone. So, in the previous video, we have seen about section of solids and simple problem in section of solids. So, now we will see another problem. So, we have seen this problem, the pentagonal prism, we have discussed in last video. So, I said that you will do it on your own in AutoCAD, right? Now we will see this problem. So, a cone of base 75 mm diameter and axis 80 mm long is resting on its base on HP is cut by a plane perpendicular to VP inclined at 45 degree to HP, cutting the axis at a point 35 mm from the apex. So we have to draw the front view, sectional top views, and true shape of the section. Right. Now we will move to AutoCAD. So as always, you have to first switch on Ortho and OSnap to make sure that all the checkpoints that is boxes are selected. Click OK. Draw a line for 300 mm or 350 mm. So this will be your XY line. So if your XY line is 350 mm, the drawing will be proportionate, right? Now we have to draw right X, Y, and all that. X. Increase the size to 5 here. Let's type 5 and enter. Now move this and keep it near your line. Now, instead of going to text again, you have to copy and paste so that you need not change the font again and again, right? X, Y. This is vertical plane, that is VP. And this is horizontal plane, that is XP. So, first you have to draw the base of the cone. So, for that, this is the command circle, or you have just select the circle. So, by default, the circle, you have to just select the center point of the circle, and it will ask radius of the circle. So, if you are willing to give diameter, you have to type D. So, now I am going to type the radius, that is 75 mm diameter, which means 37.5 mm radius. So, I have drawn a circle of 75 mm diameter. Now, from center of the circle, just draw a line. Now you have to divide this circle into 8 equal parts. So for that, you have to use a command called array, ARRAY. Select the object which you have to multiply. And I select this line, which I have to multiply. Select polar. Select center of the circle. So in the dialog box, you just change number of items from 6 to 8. Now your circle is divided into 8 equal parts. Now you have to name every part. So you have to name in anti-clockwise. So A. Now copy this A and paste near here. This is B. This is C. D. E. F. G. And H. Right. So now you just project all the points of the circle to XY line. You just project all these points to XY line. Okay. Now we have selected these are projection lines. So you just select these lines and change the color. Select the last line and double click. A dialog box will open. You can change the color of the line. So from the center, this is the center apex. So you have to name it as O, right? You have to name the center as. This is the center. Center should be named as O. This is O. So the projection line from the center, from there, the height of the cone is 80 mm. So from the projection line from the center, you just draw a line for 80 mm. So that is height of the cone. You join all the other points to the apex. So the highest point, this point where all the lines join, is called as apex. Okay. So now we have drawn the front and top view of the cone. Now we have to draw the cutting plane, which cuts the cone, right? So when you go back to the question, so cutting plane is inclined 45 degree to HP, meets the axis at a point 35 mm from the apex. So from apex, that is from this point, the cutting plane is at 35 mm, right? So first you have to draw a line at the apex like this. I have drawn a line at the apex. Now I have to just offset this line for 35 mm. So offset, you just drag the mouse to a point below that line and type the distance as 35. Okay. So you have just offsetted this line for 35 mm. So now this cutting plane is now parallel to HP. Now it should be inclined at 35 degree to HP. So just I have to select this line and type rotate base point. You just select the center of this line as base point and rotate it by 45 degree. Now I have rotated this line by 45 degree. Now I have to mark the points. So this is the point from A. So this will be A dash, right? Similarly, this is B and H. So this will be, this point will be B dash within bracket H dash. Similarly, this is C dash within bracket G dash. So C dash within bracket G dash. Right? Similarly here, so this will be D dash within bracket F dash. So D dash within bracket F dash. And finally, here, this will be E dash. So as I already said, we have to project the cutting planes here also in this particular point also. So I will just so this is O dash, right? We have to, so this is O dash. So OA we have to project here. Just project this point here. Similarly, project these 2 points here and project this particular point in these 2 lines. Similarly, project the point from E. Just draw a circle from here up to the radius of, because you cannot project these 2 points here. So to compensate that, you just draw a circle here, right? Now connect these points using spline. Spline spline, and connect these points. You have to draw a line from here. You cannot project this line here. For example, you are having the section of OA. OA is here, the cutting plane is cutting here. So you are projecting this to OA. Similarly, you can project for OB and OH and OB and OH respectively. Whereas OG is a straight line, you cannot project directly to OG and OC. So OG and OC is a straight line. So you cannot project this point directly. So it will not intersect anywhere. So to project this, you have to draw a line from this point to the last generator. That is, this is the last generator, right? So you have to project up to this point, and then you have to project this to this horizontal line here, right? Now you have to draw a circle with this radius, right? So now I will mark the points, right, using a donut. Okay. So first point of the section is here, right? Similarly, second point of the section is here, and third point of the section is here. Similarly, fourth point of the section is here. This is the fifth point, and this is the sixth point, right? This is the sixth point, and this is the seventh point. Where is the eighth point? So eighth point is here. So this is the eighth. So this is the section view, right? Now you have to join these 8 points using spline command. Type escape to get out of donut command and type spline. Connect all these points. Don't confuse the letter O with donut, right? Join and enter. Now your spline is drawn, so you can delete this circle, and you can very well delete the donuts that are used for construction if you are not comfortable with them. Okay. Now you can just trim the unwanted projection lines like this. You can trim this, right? So now you have to hatch or shade and show this. This is the section to top view. So if I cut a cone with an inclined plane, this is how the top view of the plane will cone will look like, right? So now I have to hatch to show the section. So command hatch and pick a point like this. You should be very careful in choosing the hatch, because when you're drawing this spline command, you should make sure that this curve is closed. Otherwise, this hatch will not work properly. See, it's going everywhere, which means the curve is not closed, right? So the curve should be closed for the hatch to work properly, right? So this is the section review. Now we have to draw true shape of this section. So this is the section top view. So what is the true shape of this section? For that, you have to draw a parallel line to this cutting plane. So just you select this cutting plane and type offset. You don't need any distance, just you are not having any distance. I will offset it by 50 mm. So I have offset it by 50 mm, which means there is a parallel line to this cutting plane by 50 mm, just to reprising this XY line. So we are rotating this XY line parallel to this cutting plane, right? So you can name it as X1, Y1. Now I have to draw these cutting points perpendicular to this XY line, right? So to draw, you have to just switch ortho mode off. You have to just switch ortho mode off. Actually, I have to draw inclined lines. So you listen very carefully here. So you can see L shaped here, right? You can see a L shape. So you can see L shape here, which means the line is perpendicular. So here you cannot see the L shape, whereas here you can see the L shape. Wherever you see the L shape, you just fill the line here, right? So I have drawn first line. Similarly, you have to draw for all the cutting points. So this is another cutting point. So I have to draw for all the other cutting points as well. So you are seeing L here. So whenever you see the L shaped. So for this thing to show, the beginning of the drawing, you should make sure that the OSNAP command and all the checkboxes in OSNAP command is on. Then only the perpendicular symbol will show off in the while you're drawing, right? I have drawn everything, right? Now I have to measure the distance of these 8 points. For example, a point cut at A and E are at equidistance. Similarly, H and F are at equidistance. H and F are at equidistant. Okay, right. I have to measure each and every point. For example, I have to take dimensions, annotate linear dimension. First thing, from this XY line to point A is 52.39, right? Similarly, from XY line to these 2 points, 35.2, and another point, XY line to another point, this point, 69.73. Similarly, for other 2 points, you have to take the dimension of all the points. from XY line to this particular point. 35.97 this is, and from XY line to these 2 points. 38.8 and 61.1. 61.1. Only these 2 points. $35.97 $68.8. So these are the distances we have got for all the points, I think, except this point. So this is same 52.39. We will not go again for this, right? So first, the A is at 52.39 mm. So you have to draw a line from here. So now you are drawing, while you are drawing, we can see dotted line and a word called extension here. That is the correct procedure. So it should show dotted line and an extension symbol. So you have to draw for 52.39, right? $52.39 and draw donut as soon as you drawn this, right? Otherwise you'll forget, it will create. And while joining these donuts, you should be careful. The curve should not be open. So if the curve is open, we should not be able to hatch it. So you will not be able to hatch it like this, right? So this A is at 52.39. And we will go for B. So B is at a distance of 69.73, right? So from here, you have to draw a line for 69.73. So I have drawn a line for 69.73. Just press up arrow mark. You will get the donut command. And just place a donut there. Right? So you have completed B. Now go to C. So this is the C. So C is at 68.81, right? So C is at 68.81. We have to draw from here to a distance of 68.81. And press escape. And again press up arrow mark twice, you will get the donut command and select. Now you go to D. Where is D? So you have completed C, and here is D. 61.1. So D is at a distance of 61.1. So you just draw a line for 61.1. And again, twice up arrow mark. Sorry. Donut 2, 4, enter and 61. We have completed D. So now where is E here? So this is the point E. Right? Where is E? So this is E. So the cutting point is here. So E is at 52.39, same 52.39, right? So we have to draw a line for 52.39 from here. 52.39. Here is E. Now again, twice up arrow mark, donut 2, 4. There you have this. Right. So E is over, and where is F? So here is F. Distance is wrong actually. Right. You can see is wrong. So I will measure again. Linear. So F is somewhere here. Right. So F is here. Measure up to XY line. F is 41.19. So F is 41.19. So E is over and F should be here, right? You take a line. (41.19). This is F. Here is F. Just draw a small line as an indication. Draw donut immediately. So draw a donut immediately. So that will not be any confusion. So this is F, right? After drawing the donut, you just remove that line. I am drawing donut immediately to avoid any confusion, right? So I have drawn F and G is here, right? So you can see the distance of G, that is 35.97. So I will draw 35.97 from here. You can draw 35.97 from here. So you can zoom and drag as much as possible to avoid any error, possible error, right? If you are not sure, you just zoom and place at the center of this first donut you have drawn and just type 35.97 and type enter. So you would have got your line here. And just as previous thing, you just draw a projection line to indicate where the line ends and draw a donut immediately to secure it, right? You have got another line and you just got another point, that is B. So that is over. That is 35.2. Okay. So this 35.2. You have to just draw a line from 35.2 from here. So again, if you are not confident, you just zoom this donut and place the pointer at center of the donut and leave the mouse. And just type 35.2 and type enter. That's all you have to do. And you just leave a projection like this and complete the donut. Now the bigger task is joining these donuts, right? You have to join very carefully so that the curve will be closed, and only when the curve is closed, you will get it to hatch. You can hatch the curve, right? So just type spline. Start from the position where you are comfortable, right? So you are having 8 points. You have to just click only 8 times. And the final closure should be an enter button, right? So just click. If you go for multiple clicks, so this is wrong. This is not a closed curve. So I have to draw it again. Hope you understand, right? So just to start and go with a single stroke. Then your curve will be perfect, right? Try for a couple of times. It's coming, it's fine. It's not coming, no problem. You can try it again, right? So that's it. Now I have got the curve. Only when I give hatch command, and I will know whether the curve is closed or not. Only when the curve is closed, you will get hatching like this, right? So I have drawn. So escape to get out of the hatch command, right? So this is the front view of the prism and top view. This is the sectional top view. So when the prism is cut, how will be the top view? So what will be the true shape of the section? So how will the sectioned cone will look like? The true shape of the sectioned cone. You are sectioning it with an inclined plane. How it will show here, show up here. So you just imagine the shape to be here in 3 dimensions, right? This is how the cone will look like. So what are the commands we have used? We have used circle, donut, offset, rotate, hatch for this drawing. We have drawn a cone, front view and top view of the cone, and we have drawn a cutting plane which is inclined to HP, and we have drawn sectional top view and true shape of the section. So this is the sectional top view. This entire thing here, it is called as sectional top view, and this is called as true shape of the section, right? Thank you.